So today we're going to be using trigonometry to find our missing side length. This is our third lesson. It is Wednesday. On Friday you're going to have a short quiz. You're not learning any new material on Friday, you're just having a quiz. So Friday's sort of just a day to make sure you're handing in your homework assignment and so forth. Today what we're going to be doing is we're going to be using trigonometry to find a missing side length. This is one of the most common applications of sine, cosine, and tangent. If you are struggling with how to label your image, what I would do is go back to lesson 10-2 and watch that video. What we're going to be doing shortly is we're going to do this learning target of how we're going to apply SOHCAHTOA by using a triangle to find a missing side length. And just giving you a heads up, in each of these triangles, you're going to see that we have a right angle. And the right angle is what makes this trigonometry work. You can use trig in non-right triangles, but we go into these things called the ambiguous case. But you don't learn about that until you get into Algebra 2. So the way to find a missing side length of a right triangle is actually quite straightforward. Typically we would use Pythagorean theorem, but if you look at the images, we have one side length that's given to us. So we have an 18, a 6, and a 34. And then we have x. We don't have any other information. So this is when trigonometry plays a role. You use trig when you can't use the Pythagorean theorem. So as we go through this question to the right, this question right here, where we have to find x to the nearest 10th. I don't feel like rounding that much. We want to find x to the nearest 10th. All we're going to do is basically follow along with the steps in red. Step 1. Identify your reference angle. Remember, your right angle is never your reference angle. So in our image, this 42 right here is our reference angle. I'm going to label it in green. This 42 is our reference angle. That's the easy part. Step 2, and you need to do this for every single problem. You need to label your opposite, your adjacent, and your hypotenuse. The first thing we label is always our hypotenuse, which is across from our right angle. So in this situation, 18 is our hypotenuse. The next part that we label is our opposite. So we go across from our reference angle, and we hit our opposite. Last but not least is our adjacent. Step 3 says, determine the trig function. Am I going to use sine, cosine, or tangent? So what I'm going to do is I'm going to write out SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All you have to do is look. Where's my variable? Where's my other side? I have information about my opposite. I have information about my hypotenuse, which means that I have to use sine. I can't use cosine because I don't have any information about my adjacent. And I can't use tangent because I don't have any information about my adjacent. So now that I see that it's sine, I simply set up my proportion. Because step 3 says, determine the trig function. We know it's sine. Now we set it up and we solve for x. Here is how you do your setup. You write down sine of 42 equals your opposite over your hypotenuse. Your opposite was x, and your hypotenuse was 18. The sine of 42 is really over 1, because anything divided or anything by itself is just really over 1. It's really over 1. So now we cross multiply. I multiply 1 times x, and I multiply an 18 by sine 42, and I get x equals 18 sine 42. Now remember, your calculator has to be in degree mode because this is 42 degrees, not 42 radians. So I type it into my calculator. If you're at home, you would do this on Desmos. And I'm only going to round out to the nearest tenth. My answer is x equals 12.0. That is all you do. You label your sides, identify your reference angle, figure out your trig function, set it up, and solve for x. It's typically 2 to 3 steps tops. Now we're going to do a different example down below. Remember, step 1 was identify your reference angle. If you've struggled with a problem before, you should definitely watch me do this one. And then you should definitely try to do the third one by yourself. If you were like, oh, I understood the first question, go ahead and try to do these next 2 questions by yourself. So again, we want to label our reference angle. I'll label it in green again, just to be consistent. And now we label our sides. So for instance, we always label our hypotenuse first, which is across from our right angle. So x is our hypotenuse. Our opposite is right over here. And our adjacent is always our last but not least. It's our 6. So when I'm doing this question now, the next thing we want to do is we want to figure out what we have information about. So we identified our reference angle. Step 1, it's 28 degrees. We now need to figure out if it's sine, cosine, or tangent. So one thing I like to do with every single problem is I like to write down so, ka, toa. And then this will help me figure out which one I need to use. So I have information about my adjacent and my hypotenuse. So I can't use sine because that gives me information about my opposite and my hypotenuse. But I can use cosine because I have information about my adjacent and my hypotenuse. Our next step is to simply rewrite cosine. We now write our reference angle because you're always finding the cos of an angle. And that's equal to your adjacent, which is 6, over x. This is one of those examples where it goes from 1 or 2 steps to actually 3 steps, but I promise you it really isn't that bad. Always put your cosine of 28 or your sine whatever over 1. It makes your cross multiplying easier. I now cross multiply. 6 times 1 is 6. And then I get x times cosine of 28. I'm giving you a heads up. The thing that a lot of people mess up with is that they forget that cosine of 28 is actually a number. If you go to your calculator, go to Desmos, and you type in cosine of 28, you're going to get a number. Thing is, it's a long number, so we just leave it as cosine of 28. Our next step is to divide both sides by a cos, or a cosine, of 28. My cosines cancel, so I get x equals, and I type this into my calculator, 6 divided by cosine 28, and I get 6.8. If you're stuck, if you're stumbling, rewatch this part of the video. If you're like, I understand this, go on to the next part. Try to do question number 3 by yourself. So the first thing we do is identify our reference angle. Our reference angle is 63. And now we identify our hypotenuse, which is the side across from our right angle. We now identify our opposite, which is across from our reference angle. And then last but not least, we have our adjacent. So 34 is our adjacent. So now we need to figure out, which is it? sine, cosine, or tangent. So what Miss Kimmick and I always do is we rewrite so, ka, toa. We now go through the information. Do I have information about my opposite and my hypotenuse? I have information about my opposite, but I don't have information about my hypotenuse. So I can't do sine. Cosine is adjacent over my hypotenuse. My adjacent is 34, but I don't have any information about my hypotenuse, so I can't do cosine either. So by default, I'm going to have to use tangent. So tangent of my reference angle equals opposite over my adjacent of 34. Remember what I said before? We always put our trig function over 1. Now that I have tangent of 63 over 1 equals x over 34, I'm going to cross multiply. So I cross multiply and I get x equals, because 1 times x is just x, equals 34 tan 63. Again, you just type this into your calculator. And I'm going to get 66.7. That's your final answer. Remember, to make sure that you get attendance for today's class, you have to comment on the Google Classroom. You have to write down one question you have about this video. And if possible, respond to another peer. Remember, make sure you're working on your weekly homework, which was given on Delta Math. If you have any questions, please don't hesitate to email me or Miss Kimmick. If you're still stuck, make sure you watch this video again, and don't forget to try your independent practice, which is due tomorrow at 11:59 p.m. All right, please reach out if you have any questions.